Dr. Chrzanowski's 50th anniversary with UNB. What a milestone, right? It's actually a milestone in a way that I share with Adam, but in very different circumstances. So Adam Chrzanowski arrived here in 1964 as a young postdoc, well into a career that would become just simply outstanding. And I showed up as a freshman, deeply dazed and confused, a bit more different. Right? And Adam was a child growing up in World War II and had seen a lot and been part of a lot by the time he got to Fredericton. And Fredericton must have looked like the absolute end of the planet, right? And yet for me, it's the only world I knew. I don't think I'd been out of York County in those days. So coming from very different worlds, and our paths did not cross for a while. There may be a few people here remember it, but in my day, surveying engineering, it was a 5-year program. And effectively, we were civil engineers for the first 3 years. So I took I had a theory of structures. Believe it or not, we took a course in concrete. A little bit about concrete for a while. But in fact, other than Gerhard, who was the face of surveying engineering, we really never met the faculty. And I really first sort of came in real contact with Adam Chrzanowski. I don't know if it was 3rd year or 4th year, but it was my introduction to engineering surveys. And it was quite an experience. Even almost half a century later, I can remember, not the facts. As you know, I always had a tenuous command of facts on any subject. I certainly don't remember engineering surveys. But what I remember was the environment. Adam, for his part, had a very, very tenuous relationship to English in those days. It was hit and miss. And he brought to Canada a set of mathematical tools from the old country, sort of a Polish precursor to matrix algebra that was deeply confusing. So I actually remember a class that got off to a rather, suspect start. But what really got to all of us in my class over time, and it became so obvious, was his passion and his commitment both to the subject and to his students. And he represented the very best of what our department was about. And from that day forward, I always had this very, very special image of Dr. Chrzanowski in the classroom and bringing in a wealth of experience, lots of professional details, case studies, and then threading that into the academic narrative with gusto, with passion, and with a commitment to his students that was quite remarkable. So thereon, Adam went on to have just a brilliant career. He's one of the giants in engineering and mining surveying, with a tremendous legacy. The list of awards that he's received, the impact that he's had. My wife Maggie and I had a chance to see just how important a career he had and how it was recognized. We were in Poland one time with Anna and Adam, and Adam was receiving an honorary doctorate, and the president of Poland was there on that occasion. And I'll always remember just how important the academic world was treated, right? How serious what we do was treated. And I'll always remember the respect that Dr. Chrzanowski has received, both in terms of his intellectual contributions, his contributions to the Polish community, and to society more generally. So he's had an outstanding career, and testament to that is an amazing set of awards and recognition that he's received. His most recent recognition, which I happen to believe is more important than all of us, he's also now a grandfather. And that's a pretty important step as well. And his granddaughter, Mama and Clara, are here with us today as well. Of course, unlike a lot of folks at 65, Adam didn't walk away from his professional career. He and Anna had developed a very close, very important collaborative arrangement that's still extremely important and making a real difference. So we're here to celebrate the career of an amazing individual and to pay tribute to his accomplishments. And if I may, just another minute, I'd like to conclude by putting Adam's career within the context of surveying engineering, too, if I can. The department changed its name in the mid-90s for all kinds of great reasons. And it's moved on to new directions, and it's doing amazing things. And the Department of Geodesy and Geomatics Engineering in due course will have its story told. But we're sort of running out of opportunities to talk a little bit about surveying engineering, because the pioneers are not always with us. And if I could just say a couple of words about that 30-year period where it was the Department of Surveying Engineering and the role that Adam played in that. I've thought about this a lot over the years, and it's a unique academic story in Atlantic Canada. There's no other academic department that I know of, and I certainly had a chance, especially when I was president, to go around to other universities and have a look. There's no other academic department in Atlantic Canada that ever was the best in the world. What was that? It's not that there weren't other good departments. There were departments with outstanding individuals, geodesy or photogrammetry, or pick your subject. And certainly outside the English-speaking world, Europe, and especially Central Europe, had lots of fine institutions. But there was a period when this department was the best, absolutely the best. And you know what, it's a history we still haven't properly recorded or reflected on. Lots of reasons for why it came together and how it was shaped, and some terribly important actors. And I'd like to mention just three. First, of course, was our leader, Angus Hamilton, the great conductor. Right? An orchestra, prima donnas, soloists, strange crowd trying to keep focused, but he did it. And probably he was the only individual who could have done it. So, our leader, Angus Hamilton. Someone who's with us today and also played a terribly important role and often under-recognized was Gerhard Klaus. We, as scholars and researchers running off with our own agendas, we often forgot that our raison d'etre, our primary reason for being, was as an undergraduate engineering department. Gerhard provided the face. Gerhard provided the relationships, the connections. Terribly important, and something we haven't acknowledged enough. And then we had this gaggle of sort of world-class academics running the gamut from pure sciences right through to, I guess you could call my field, if you wanted to give it a nice thing, institutional geography. And we spanned a lot of different approaches, perspectives, and values, and priorities. But you know what? At the end of the day, it was an engineering department. It was a professional engineering school. And I think the individual more than anybody who defined our field, defined surveying engineering, was Chrzanowski. He brought forth an institutional history from Europe that had standards and expectations much higher than we were used to. Living in economic geography with intensive resource management, the tools and the processes were much more highly advanced than here. And taking that world and the new world with its technologies, the positioning, the computers, and welding that together. And then also taking both an academic and a scholarly perspective, but also weaving into it a world of professional practice and how they interrelated. There was nobody nobody, who brought all of that together at the very core of what we were as a department. This absolutely world-class department from Dr. Chrzanowski. It's a very important career. It's a career of personal excellence, but also an amazing contribution to something bigger than all of us individually. And I'm so proud to have Adam Chrzanowski as a person teaching, then for a long period as my colleague, and for me, more important than all of that, as my friend, Dr. Chrzanowski.
Thank you, John, for your kind comments. I really appreciate it. First of all, I would like to thank all of you for coming today. It's a really big day for me. It is like second retirement, hopefully not the last one. Thank you very much, the Vice President of Research, the Assistant Vice President Academic, for making your time available to come today. I appreciate it also. I'm very happy to see some of our students. Hopefully they will gain something from the today lecture, although it will be just a summary of projects rather than details. Thank you all friends, all colleagues. First of all, I would like to thank to Marcelo Santos and my colleagues from the department that they have remembered at all that I existed for 50 years. And I was pleasantly surprised when they came with the proposal, Adam, we should organize something on the occasion of your 50th birthday. Not birthday, sorry, it would be. But on the occasion of your 50 years of work at UNB, it's been a long period of time, but I tell you, I have enjoyed every minute of this 50 years working here at UNB. I had always a very friendly environment, cooperative people, and particularly in our department, we had a spirit of friendship and cooperation. I enjoyed it. So now, not to prolong more, I go with my lecture. 50 years. For young people, it sounds more like half a century. For me, when I look back at 1964, it's as it would be just 3-4 years ago. It goes so fast. Only because I really enjoyed my time spent over here. Once you enjoy your work, your time passes very fast. Been always my advice to any students. If you have a choice of more than one job offer, select not the one which gives you the best money, select the one which you are sure you will enjoy in your life. Finally, you are spending so much time working, you have to like it. Now, about the spirit of friendship, cooperation, I would like to start with a picture. It symbolizes the whole spirit of at UNB and particularly in our department. The picture was taken 28 years ago on PI. After hard working, we decided to have a few days vacation in PI. I would have many more pictures, similar ones, but we have to go into something more serious. So, when I came to Fredericton, I was supposed to spend just 1 year as a postdoc fellow and to help developing the new department of surveying engineering. After a certain time, feeling this friendship and cooperation around, I started changing my mind that maybe I should stay longer. Another factor which influenced my decision to stay longer was Mount Kennedy expedition, which I am going to show in a few minutes. That with these two factors connected together, at the end of the first year, I said to myself, Adam, your future is with UNB. And so I'm here after 50 years and still enjoying my time. Mount Kennedy expedition in early 1965, a few months after my arrival in Fredericton.
Maybe switch off some of the light. Yeah. It's hard to see.
Yeah, that's better.
Good, good.
Maybe this one is more important to
Yeah.
switch off.
Yeah,
Yeah.
great.
In early 1965, January or February, the Geographic and the National Geographic Society and Boston Museum of Science decided to organize an expedition to climb for the first time Mount Kennedy, which was named by the government of Canada at close to the border of Yukon and Alaska. And they invited us to perform one part of the expedition to make the map of the whole area. To see Alaska, it was always my dream of my childhood. So when I heard about the invitation, I said, oh yes, yes, I'm going. I volunteered immediately. And here I was, yeah. I became the part of the UNB team. Here you have in the middle, Dr. Gottfried Konechny, the initiator and head of our program in surveying engineering. On the right, Peter Wilson, assistant professor from South Africa, and myself. There was still one more faculty member who was supposed to compile the whole map later on, and three of us were supposed to do field surveys to provide a few ground control points for area photogrammetry. The first part of expedition went quite well, I would say. It was sunny weather. Robert Kennedy was brought from Whitehorse by helicopter to about half elevation of Mount Kennedy, and the next day, with assistance of the members of the US Mount Everest climbing team, he made to the top. With one small accident, he went to a crevasse for a while, but they got him quickly out. When he came back, he said, I am glad I went up. I am glad I came down. That was much more difficult than I anticipated. From now on, I plan to stay on the first floor of my house. And then we arrived at the base camp. The weather in the beginning was very nice. We were supposed to use the state-of-the-art equipment of the time. It was microwave tellurimeter for measurements of long, like 20, 30 kilometer distances, and modern geodelites at the time. The transportation to the survey points was provided by small airplanes on skis, which could land in the reasonable vicinity of survey points. The rest of the way we had to hike with the tellurimeter, theodolite tripods, batteries on our backs. It was physically quite demanding, but the weather in the beginning was beautiful. We thought that we would complete the task in about 10 days, the whole survey. Unfortunately, the weather turned bad. Snow blizzard after snow blizzard, no visibility. Planes could not land on the glaciers. So we really delayed our work and delayed. In some instances, the planes could not come pick us up on time. In the base camp, my small tent was getting deeper and deeper in snow, finally collapsed completely. Here is a misery camp, we called it, because we had to stay for 6 days in the small camp waiting for an airplane to come, and we had food supply only for 2 days. It was quite an experience. In our group, there were 5 of us in the small camp. There was also a sociologist taking like research on the behavior of people in difficult. And we watched him. He was the best to watch, really. After 2 days, no more food, what to do? He was quarreling. Where's my spoon? Where's my mug? It's mine. Everything wanted to hide behind himself. Finally, after 6 days, the plane came, we survived. We came back to Fredericton after, I think, 5 weeks spent in the field. And Gerhard Bloss took over the job of compiling the air photographs, our data from measurements. He prepared a beautiful manuscript, which was sent to a cartographic institute in Switzerland for final printing. Is it, Gerhard?
No,
No?
they came to Washington.
Yeah?
The Swiss came to Washington.
Ah, I heard that program in Switzerland. This is the fragment of the map. Coming back to Fredericton, we continued our work on the development of surveying engineering. 1966, 2 years after my arrival, we moved to this building, which was just finished at the time. We got new laboratories for our research and teaching. This is A17 for those who know the area. And note, oh, sorry. Note my white shirt, tie, vest, and jacket. After 2 years, I still had the old customs of European universities that in order to show respect to your students, you should be properly dressed. And of course, later on, I changed it. It was not very practical. And I started continuing my projects, which I had started earlier in Poland, applications of laser technology to the development of new surveying techniques. This is a laser plummet, a prototype we patented together with Dr. Masri. It's a pity I don't see him today. And nobody bought the patent, so we didn't get rich, but it was quite a satisfaction. A few years later, a known-built company in Switzerland, they built a laser plummet based on similar principles, but they changed a few things, so they didn't have to pay anything. Then there was my first PhD graduate student, Dr. Fuad Ahmed from Egypt. He developed a laser plummet of high precision, and then we worked together on the development of motorized trigonometric high traversing, a project for geodetic survey of Canada. At the same time, we conducted a research for the National Defense Research Board on the propagation of laser beams in turbulent atmosphere. Apparently, the results of the research were used by them in the research on developing laser-guided missile systems, where it was important to know the behavior of the wavefront of the laser and so on. So it was quite interesting. Simultaneously with our research, we tried to improve also the status of mining surveying profession in Canada. I was astonished when I asked all major mining companies in Canada and in the States about the educational background of their chief surveyors. Most of them answered that they were on the job trained in the best technicians in surveying, but in many cases there were foresters or even chemists taking care of the surveys. So in 1969, we organized the first Canadian symposium on mining surveying at UNB. As a result of the symposium, we created a year later a National Committee on Engineering and Mining Surveys at the Canadian Institute of Surveying. Then 74, we had second Canadian symposium, and 76, Canada was one of the co-signers of foundation of the International Society for Mine Surveyors. And I serve till today on the presidium of the society, not doing anything. So altogether, in 1970s, UNB became the only university in North America to offer specialization in mining surveying and engineering surveys of high precision at both undergraduate and graduate levels. In the early 70s, we expanded our research into monitoring and analysis of structural and ground deformations. One of our first projects was in Peru, together with the Department of Geophysics at University of Alberta. What happened here? In 1970, this part of the Huascaran Mountains, so a huge portion, this is a 6,000 meter peak, collapsed, and the avalanche of ice and rocks came at the speed, they claim, over 200 kilometers per hour, and buried 2 towns, killing 45,000 people. It was quite a disaster. And geophysicists of University of Alberta wondered whether 5 years after this earthquake there was still any residual ground movement visible over faults activated by the earthquake. So we developed a method of micro-geodetic networks across active faults to measure relative movements of the points. Mind you, we didn't have yet at the time GPS, so we had to use terrestrial methods. And here is Mark Denler of South Africa, a graduate student, and here is Anna, who at the time was a graduate student of mechanical engineering at UNB. She is always hot, so she felt very comfortable. The main problem of the project was not technical, it was the high altitude. The projects were at the elevation of about 5,000 meters, and at that elevation not everybody is capable of doing work. It depends on the chemistry of your body. Some people, strongly looking, suddenly they collapse because the blood cells start disintegrating. And then you have to take the person immediately as low as possible in order to survive. So each year I would have to send at least 3 graduate students, hoping that 2 of them will survive. Another project in deformation surveys was at Sparwood Coal Mine in BC, which was performed together with Dr. Wolfgang Feib, present here, and with the Department of Computer Science and Physics, to develop a system for continuous monitoring of slope movement above a steeply inclined coal seam, 12 meters thick, which was taken out. And there was a suspicion that there was a discontinuity in the rocks, a fault. So we had to perform measurements continuously in the harsh climate conditions, 5 meters of snow in the winter, so we could not apply any optical surveys. We decided to use the tellurimeters, arrays of tellurimeters which would sense the ground movement. The system worked really well, and after 2 years, we discovered that indeed there was the fault, which would produce at that time about 1.5 meter already sliding of this part of the mountain. Operation to monitor slope stability in drag line operation. And here one more example of our ground movements. It's ground subsidence studying oil fields in Venezuela. Due to the extraction of oil since 1927, the land was already about 6 meters below the water level of the lake in 1984. And we were asked to monitor the stability of the dike. It was 52 kilometers long, and stability of the inland area. So we started this project. It was James Seacott involved. If you remember James, our trips to Maracaibo. And it came time really to develop some newer methods of measurements to make the measurements more economical. So we decided to use, it was the pioneering use of GPS. 1996, we had very few GPS satellites in orbit. 86, I think we had only 7 satellites. And to see 4 of them simultaneously with from 2 stations, which was necessary to determine the relative position. We had a window of opportunity for measurements from 2 a.m. to 4:30 a.m. So every night we just use this 2.5 hours to see 4 satellites to do the measurements. Of course, with time the situation improved because the number of satellites was growing. So by 1990 we could perform almost normal surveys as we do them now. What was interesting in that project, that we noticed from the surveys that the baselines measured along the large body of water, and baselines measured 20 kilometers inland in very dry climate, that there were some discrepancies perhaps due to tropospheric meteorological conditions. To prove it, we used balloons with the meteorological sensors, with the telemetric data acquisition, and we sent them up to 1,000 meters, scanning the atmosphere, and indeed we noticed large discrepancies between the profile of humidity of air inland and along the coast, which would significantly change the results if not corrected for. So it was one contribution. We carried this project until 1992. In 1980s, there were 2 major developments which really changed our approach to deformation surveys, structures and deformation. The first development, the main contributor was Dr. Chen Yongqi of China. He got his PhD from us in a record short time, as for our department, in 25 months. And he became later on professor and head of land surveying department in Hong Kong. The geometrical analysis he developed was done through optimal least squares fitting of selected displacement functions to any type of geodetic and geotechnical deformation measurements. Another major development was done by Anna Chrzanowski, who at the time was finishing her PhD in rock mechanics. She developed an interdisciplinary approach to physical analysis of deformations using principles of continuum mechanics and finite element method. There were some followers of hers, like Dr. John Obundare, got PhD on the topic, Jason Bond, present over here. He partially used in his PhD thesis Now it's still being done by Maciej Chrzanowski, our research assistant, and a graduate student in Poland. At the end of 1980s, we really got a good recognition, international recognition. We organized the 5th International Symposium on Deformation Measurements at UNB. I became a chair of the International Study Group on Deformation Surveys, and I chaired it for 25 years until 2010. By 1990, UNB gained an international recognition as a world leading center in integrated monitoring and analysis of structural and ground deformations. The two developments which I mentioned of 1980s was first applied at the Mactaquac Dam here near Fredericton. The dam was constructed in the mid-1960s. A few years later started showing some strange deformations, cracking of concrete. First, we thought that it was a ground movement surrounding the dam because some geologists claimed that there was an active fault under the dam. This was not proven. Then dozens of various instruments were put in the cross-sections of the powerhouse, like Korfol extensometers, lam lines, joint meters, and so on. But all these individual measurements were difficult to interpret what was really the mechanism of the deformations. So only after applying the generalized method of geometrical analysis by fitting some displacement function, we obtained a real pattern of displacements of the dam. It was swelling of concrete. It was a phenomenon known as an alkali aggregate reactivity, that when concrete having too much alkali will start swelling when exposed to humidity. And this was the case. At the time of building the dam, this phenomenon was not yet known to civil engineers. Therefore, it was really discovered only later on, and we proved for the first time at the Mactaquac Dam the existence of the phenomenon. The same was applied at the Warsak Dam on Kabul River in Pakistan, where with our measurements we also discovered that the deformations of the dam, some gates were not closing. It was alkali aggregate reactivity problem. What was interesting about this project, that the dam was located only 20 kilometers from the city of Peshawar at the border of Afghanistan and Pakistan. During the Russian occupation of Afghanistan, so before 9/11 really happened, thousands of refugees came from Afghanistan and settled in Peshawar. They brought with them many interesting things to trade. And for instance, we were offered at the market, we could buy shoulder-held anti-aircraft missiles for about $300 each. We could even buy a tank, Russian tank, still in a working condition for less than $3,000. We didn't buy, of course, because I was afraid of the Canadian customs. Now it comes the time of our most prestigious project, or at least of my time. It was the construction of the largest in the world collider of subatomic particles, so-called Superconducting Super Collider, to be built in Texas at a cost of $10 billion. It was to simulate Big Bang theory of the universe creation and to find subatomic particles smaller than quarks. The collider was to be placed in an 87-kilometer elliptical tunnel connected to the surface every 4 to 5 kilometers by vertical shafts. And then 12,000 of the magnets, some of them even larger than you see in the back, were to be aligned in the tunnel in a perfect geometrical plane in inertial space. So it was not like a horizontal plane, but perfect plane in inertial space. This produced many geodetic problems, how to correct the measurements to get really everything spaced in the perfect plane. We had to employ quite a few geodetic engineers and specialists in tunneling surveys and engineering surveys. And altogether there were 18 geodetic engineers, 14 of them from UNB. So US Department of Energy asked, why so many Canadians on our project? And they have to explain, because there's no other university in North America which would produce the specialists we really need. So it was a big error that of this whole project. Here's geodetic control for tunneling surveys. We use GPS, geodetic leveling gyrotules like laser plummets, and various metrology equipment. James Icod was also involved in the project. Even the survey pillars had to be controlled for the local stability. For example, here it is shown one of the pillars which was controlled by an inverted plumb line. It is floating plumb line on the top, anchored several meters under the pillar in the bedrock to control the movements eventually to temperature changes and other factors. Here is the first tunneling breakthrough. After the first 4.5 kilometers between two shafts, the boring machine coming from another shaft broke through. Everybody excited to check what was the discrepancy between the axis of the boring machine and axis of the tunnel as designed. Everything came to about 4-6 millimeters. So it was very good. So we've got some name in this area, and even Maclean's Guide to Canadian Universities wrote 3 years in a row, I believe, this statement. The project of that scope had never before been attempted. As a result, the university's involvement excited international attention and raised its prestige. Very nice. Then came 1998, my formal retirement from UNB, but I still continued with my research team at the time, still get quite a few graduate students. And we developed a fully automated system for monitoring displacements using robotic deformations. The software called First Diamonds, later on changed to Aleph, is still used in many parts of the world. Here one slide escaped somehow. There is another part showing a shelter with a robotic deforestation at a large project, so-called Diamond Valley Lake, creation of the largest in California reservoir of fresh water with 3 large dams. In 2000, we established 8 robotic deforestations with our software around this this area, and the system is still working continuously for 14 years already. We are gathering very interesting results. Here.
This missing comment.
I don't know. I have no idea. Another application was at Highland Valley copper mine in Western Canada, and still another one in Chuquicamata open pit mine, the second largest in the world open pit mine, where we established also a system of 8 robotic total stations. Then in 2002, we were supposed to enter into a joint project with Memorial University, Secor company from Memorial, which was to be sponsored by ACOA, Atlantic Innovation Fund. Well, it was around one. We've got a good grant for the project, and we finished it in 2007. To enter this project, we had to work as a recognized research entity, not just a private group at UNB. So we established Canadian Center for Geodetic Engineering. We still run the center today. And the objective of our center is interdisciplinary research and industrial applications in monitoring, integrated analysis, and physical interpretation of complex structural and ground deformations, with applications in structural, mining engineering, and in energy sectors. So we are still running this project, and we have just finished last March the second ACOA-sponsored project, again together with the Memorial University. So we have done a lot of new developments. One example is design of integrated monitoring scheme at Mackenzie Delta gas fields. The problem over there was to separate ground subsidence produced by the withdrawal of natural gas from natural causes, which were, for instance, post-glacial acidostatic adjustment, tectonic movements, degradation of permafrost, changeable sedimentation load in sea level changes. The project was done for Environment Canada to see how the natural gas may influence the environment. Another example which we carry till now is monitoring and integrated analysis of environmental effects of extraction of potash and natural gas in Sussex, New Brunswick. This is very complex geology in the salt dome where the extraction goes now. It's Chrzanowski's mine, and this year they are starting the second mine in the neighborhood, Piccadilly mine, and we are involved in both. Very interesting project. We really started it already in 1989, so 25 years ago, monitoring ground deformations around Chrzanowski. So we come to the end, and we are still going and going. In the meantime, a new generation of future geodetic engineers is growing and growing. I don't know. Amelia is here or she is outside?
She's here.
Yes, so Amelia is here. I try here to become a geodetic engineer, but parents may not agree. Thank you very much.
Okay, so Adam, it's my kind of duty and privilege to say these final words as department chair. And what happens that since we came up with the invitations about these small celebrations that we're doing here, my mailbox started to be very full with lots of emails. I ended up enhancing the kind of a spam level, so probably there's still lots in the junk mail. I'm going to just get a few people that I wrote. I'll try to retrieve them. So Doug Morgan, who is the executive director of the Association of New Geometrical Surveyors, he sent his regrets. He couldn't be here, and he said, "There are heroes in my life that I hold in high regard for demonstrating what it means to engage life and unselfishly mentor others. Adam is one of my heroes." There was, no surprise, this Polish prof from Wrocław University of Technology, Professor Stefan Kakun. Is that correct, Kakun? So he said, among other things, development of a method of integrated geotechnical analysis of deformations with a physical interpretation by Professor Dr. Adam Chrzanowski deserves particular recognition. This has formed the foundations for more accurate safety assessment of the studied object in the cause and effect, not only in the effect aspect. That's pioneer work. Professor Dr. Stanislaw Ostak. Oh, that was a long letter. I'm just going to skip a sentence here. We highly acknowledge his contribution to many of our projects in Poland, including the determination of anthropocentric vertical and horizontal deformations of Polish copper mining area. So you also work in the anthropology field, right? Now, Egon Dorer, he said, knowing him, I think he will not stop working immediately, which I compliment, we do hope so. YQ Chan, I think he wrote to you, but he also wrote to me saying that he wanted to come here, but he missed the plane. And there is also some interesting thing. Sarah Bernard from Security and Traffic sent also her regards. And also she said, please drop by to pay your fine. So Mary Ogilvie sent a nice postcard. And she said, actually, she's one of your oldest, or maybe the oldest female student. So, I don't know. And that's it. So, anyway, just give a hint. What I'd like to say, a few things to close up, if I may. At UNB, Adam Chrzanowski has been geodetic and mine engineering. And geodetic and mine engineering has been Adam Chrzanowski for 50 years. And during the past 15 years, 15, probably more, actually, one more, 16. Adam Chrzanowski has been serving UNB as a volunteer. Because as a professor emeritus, that's basically what the university expects, right, for professor emeritus. And not as full-time faculty member that draws full salary from the university. So there was no new faculty member hired to work with him. And so Adam will hopefully live forever. Now I was reflecting this morning what would happen, say 50 years ago, if the university decided, instead of hiring Adam, just divert the eventual salary to a discretionary fund. When UNB would have lost a tremendous opportunity, of course. And Adam would have done his work somewhere else, which would have been a shame. But not just Adam, actually, as John McLaughlin mentioned earlier. It was, quote, a gag of world-class academics. There is a quote from the former UNB president, Zhang, who said once, "I have a strategic plan. We hire the best faculty we can and support them to be successful." Adam, I'm glad you're hired 50 years ago. So Adam, all I can say on behalf of all professors, instructors, staff, students, past and present, is that it has been more than an honor. It has been a privilege to work with you in any capacity over the past 50 years. Nice job. Okay, so, you can adjourn.